Hey, can you guys hear me, see me, and see the screen? Yellow. Okay, cool. Okay, perfect. Sorry, I'm terribly late. I'm sorry. I'm terribly sorry for being late. I'm also terribly late as well. Yeah, just the previous classes, some reason always goes like extremely extra, and I just needed to finish it quickly because some of them are writing a test in this week. Okay, but let us start. All right, so we'll end a bit late. Again, I apologize. Let's get going. Right, so assalamu alaikum and good morning. Welcome back, guys, to grade 11 physics, okay, by Inspired Teens. Today we're going to be continuing Newton's law. If I remember last time, we ended on force body diagram and free body diagram. Okay, for those of you who actually didn't watch till the end, we did go a bit extra, so please make sure to complete that video and watch till the end. Okay, today we're going to be doing a question. Okay, we're going to be practicing, I believe, Newton's first law and Newton's second law, okay, in one question. Technically like two questions, but just one diagram. Okay, so just quickly before we start, how many of you have started electrostatics? Here we have 1, 2. There you go, starting Monday. Okay, so if you, for those of you who have started, okay, that means you guys have completed Newton's up until Newton's gravitational, as well. Yeah, Newton's third law, basically. You guys have completed up until Newton's third law. Is that true? No. You guys have, okay. Yes, okay, cool. Okay, and then for those who have not started electrostatics, what are you guys currently busy with? For those who have not started electrostatics, what are you guys currently busy with? Okay, cool. Makes sense, makes sense, makes sense. Perfect. Okay, so let's look at this question. Right. And let's answer it, right? We're going to answer it together. So, an object with a mass of 3 kg is allowed to hang over a frictionless pulley with a light inextensible string that is attached to a 5 kg box. The box is pulled on a rough surface with a force of 36 newtons and is moving at a constant velocity. Okay, so firstly, let's talk about this frictionless pulley and light inextensible string. Okay, so when they say frictionless pulley, they just basically are saying that the pulley itself is not going to be affecting the tension. The tension in the rope is just its own thing and is not affected by the pulley. Okay, the pulley doesn't have some sort of tension or whatever that is, right? Cool. So then light inextensible string, again, okay, there's no other sort of influence on the tension. Right. It's attached to a 5 kg box that is being pulled rough. Okay, so we know that there's friction. There's definitely frictional force. And there's also this guy, applied force, okay, of 36 newtons in the upright direction, okay, at 30 degrees to the horizontal, okay, and it is moving at a constant velocity. Can someone tell me why is that important? What's so special about constant velocity? What is so special about constant velocity? What can we deduce from the fact that it has constant velocity? Oh, okay, that's a lot of people. means acceleration 0, blah, blah, blah. Okay, everyone is correct. Okay, so your first thing is that acceleration is 0. Okay, because remember, acceleration is the rate of change in velocity. So the rate at which you are changing your velocity, that is called now acceleration. So if there's no change in velocity, there is no acceleration. Okay, so acceleration is 0, 100% correct. Since acceleration is 0, F net is also equal to 0, because remember, F net is equal to m times a. Anything times 0 is going to be 0. So therefore, F net is equal to 0. Okay, cool. Right, so F net is equal to 0. Now we have draw a free body diagram of forces acting on the 30 kg object. Okay, so I'm going to give you guys 1 minute to do this on your own, and then we can mark it. 1 minute starts. Actually, no, you have like 30 seconds. Okay, you have more time now. It's taking me 30 seconds to set this 30-second timer. Okay, 30 seconds starts now. Please draw this, and then we'll mark it after 30 seconds. Three seconds left. Is anyone done? I hope everyone's done. Okay, either way, we're going to mark it right. So we have our little dot to indicate free body diagram to draw all of our forces from. Now on the 3 kg object, right, firstly, we have to have gravity. Okay, before that, firstly, it's 2 marks. So we are expecting 2 forces. So we have one going down. This is gravity. This is Fg. And then we have tension. Which direction is tension? Remember, when it comes to tension, it's always on the object. At the point where the rope touches the object, and you go away from the object. At the point where the rope touches the object, and you go away from the object. So it's up, correct. In that case, I have my tension in the upward direction. I call that Ft. Okay, 2 marks for 2 forces. Let's move on to the next. Calculate the magnitude of tension force on the 3 kg object. Okay, so now they want us to take it step by step. They want us to calculate the magnitude of tension on the 3 kg block. So just one thing to note, okay, when we do the free body diagram for this 5 kg object, the tension is in the left direction. Okay, again, it's always at the point where the rope touches the object, you go away from the object, on the rope, away from the object. Okay, this is the tension for the 5 kg object. Please remember that this tension 1 and this tension 2 are equal. They don't have the same direction. One is up and one is left, of course, but because it's on the same rope, they are equal. The tension on the rope is equal. Okay, so determine the magnitude of tension force on the 3 kg object. So now we are going to work with the 3 kg object only. Okay, it is not simultaneous yet because 4-mark question. Okay, what we are required to do is we are required to do an F net is equal to m times a. F net is equal to m times a, but just for the 3 kg block. That's it. Okay, because okay, someone tell me, right, how do we open up F net? What's the general thing for opening up F net to separate this into the forces? How do we do it? Any idea? I think we're all sleeping on this Sunday morning, eh? Maybe we haven't gone through it yet. I don't think so. I thought we have. Oh, is it here? Okay, we'll write it here. F net is always broken down with forces in the direction of motion minus forces opposite to the direction of motion. That's where we did that. Yes, correct. Right? Forces in the direction of motion minus forces opposite to the direction of motion. In this case, right, we are moving to the right. Okay, the 5 kg object is moving to the right at a constant velocity. That means that the 3 kg object is moving up. Okay, so in that particular case, we are going to say, what's the force in the direction of motion? Up, Ft. What's the force opposite to the direction of motion? Fg. Tension minus Fg is equal to m times A. Tension is unknown. Fg is mass times gravitational force, which is basically 3 times 9,8. Mass is 3. Oh, sorry, I'm forgetting. This is a constant velocity question. So in order to get your marks, you need to indicate that F net is equal to 0 because there's no acceleration. If this helps us in Newton's second law, that's what we're doing right now, Newton's second law. Oh, well, technically Newton's first law, but I mean, this helps with Newton's second law as well. When you take it to the other side, actually, let's do this. So you will notice that Ft, when I take Fg over, it becomes positive, is equal to Fg. So F tension is equal to 3 times 9,8. Okay, and 3 times 9,8 is 29,4 newtons. So that's how we calculate the magnitude of tension force on the 3 kg object. They didn't ask for direction, so we don't have to say up. So we've calculated T1 as 29,4. What is the value of T2? T1 is 29,4 newtons. What is the value of T2? What is the magnitude of the tension that's acting on the 5 kg object? The same 29,4 as well. Okay, remember the tension in each rope remains the same. Okay, let's look at the next question. Draw a free body diagram for all the forces exerted on the 5 kg box. 5 marks, 5 marks, 5 forces. You have 2 minutes. Won't it be negative? Okay, we don't have to worry about that because you have 2 minutes, by the way. It started already. Okay, you won't say negative. Okay, don't say negative because it will, that you'll sort it out, okay, when you open up FNet and you say forces in direction of motion minus forces opposite to the direction of motion, it will sort it out. If it's opposite to the direction of motion, it will make it negative. If it's in the direction of motion, it will make it positive. Okay, so what we are doing a free body diagram. Why am I helping? A free body diagram for this 5 kg object for 5 marks, meaning you need 5 forces. Is there friction? Yes, there is friction. It says that it's on a rough surface. I think 2 minutes is way too long. Okay, I'll wait for one more person to say done and then we can mark it. There we go. Can you please show the question? Okay, the question was a free body diagram. This was the question. Okay, so firstly, for rods, we have gravity downwards. This is a flat surface, so the normal force is straight up, perpendicular to the surface. We then have tension force. We also have frictional force. Tension to the left, friction to the left. We have our diagonal applied force. F applied or F A even. Okay, does that make sense? What we can do quickly is I just want to do the force body diagram as well, because remember, you guys need to know force body as well. So I have Fg from the center of gravity. I have normal from the surface. I have an F applied from here. I have a tension here. And on the surface, there is friction. It really does not matter which one you drew first. If you drew tension or friction, these have nothing to do with the size of the vectors. The magnitude and size of the vectors are not important at all. It's mainly direction. Okay, you could also draw it like this. Ft and Ff. Doesn't matter if you put friction first, tension first, whatever. And then there's force body. Okay, very good. Now these are, okay, whatever, right? Let's move on to this. What is the magnitude of tension T2 on the 5 kg box? Okay, we know this answer. We've answered it already. What is the magnitude? That's where they asked magnitude of tension T2 on the 5 kg box. It's same as the tension on the 3 kg box, 29.4 newtons. Is it fine to draw? Is it, will it be wrong if you broke down that into its components? Is it fine to draw? Okay. Is it fine to draw FF on the right side? Wait. What do you mean by the right side? I thought you meant like on the right side of T. Like, are you saying you drew FF like this? Please confirm with me if that's what you meant. That's incorrect, by the way. No, this is incorrect. Let me explain friction quickly. See, we're drawing it for the 5 kg object. The 5 kg object, the direction of motion for this question is to the right. Direction of motion. Okay, since the direction of motion is to the right, okay, the friction is always opposite to the direction of motion. So friction will be to the left in that case. Friction always opposes the direction of motion. I drew Fx and Fy, not Fa. Okay, I'm going to explain that. But that's okay. If you separate it into its components, you should have Fx and Fy like that. Okay, you are not going to get an extra mark. You're going to get half a mark for that and half a mark for that. Number one. Okay. Normally, for these 5 mark questions or for drawing the free body diagram, I recommend you just do it without the components. But if you're confident in your components, you can separate it into your components. Don't show both, just show the components or just show the force itself. Okay, so that's how the components would look. Now, when it comes time to do the question, that's when I would say you separate it into its components. So now they say, calculate the frictional force between the surface and the 5 kg block. So now we need to do F net is equal to M times A for the 5 kg block. Okay. Now, F net is equal to 0. Okay, Newton's first law, we're traveling at a constant velocity. Right? An object will always try to stay at a constant velocity or at rest. Okay. So now F net, remember F net, how is it opened up? How do we open up F net? Forces in direction of motion minus forces opposite to direction of motion. Let's look at this now. What is the direction of motion? Can someone tell me what is the direction of motion? Just give me the direction of motion. It's to the right, okay? when we look at the applied force is not to the right. The applied force is actually upright. Now, what that means is that the applied force itself is not in the direction of motion. The applied force itself is not in the direction of motion. The direction of motion is right. The applied force is upright. Those are clearly not the same directions. That is why now, whenever I'm going to copy this, okay, I would recommend to having two free body diagrams. One to get your marks, okay, one to get your marks without separating it into its components, and another to do the question where you do separate it into its components. Alternatively, you can just do one where you already separate it into its components and you can utilize that one. Let's just get rid of this and learn how to draw it. Whenever, right, look at our free body diagram, right? Which force, so we have firstly a vertical plane, okay, and we have a horizontal plane. Which force in this free body diagram would we regard as a diagonal force? Which force would we regard as a diagonal force? F applied, very good, right? So when I'm saying diagonal, okay, this is vertical, this is horizontal, anything else is diagonal. That, and anywhere else is a diagonal force. I want forces in my free body diagram that's going to help me to answer the question. I want all my forces to be vertical and horizontal forces. I don't want any diagonal forces. Nothing. I want to get rid of all of my diagonal forces. So what I do is my diagonal forces, I separate them into their components. Now, each diagonal force has two components, okay? And the direction of their components are easy to judge. So for example, the F applied here, if we have to describe its direction, it could be described as an upright force. So that's simple. So its diagonals, its components are going to be an up component and a right component. So I'm going to have a component up and I'm going to have a component right. And these are the components of F applied. I can get rid of F applied now. I don't want any diagonal forces. Gone. I have separated it into, you can say F applied Y, F applied X. That's what I would prefer. Instead of Fx, I would say FAY. So how do we know if it's Y? Y is along the Y axis or parallel to the Y axis, and X is parallel to the X axis. So now I've separated that into F applied Y and F applied X. So if you remember from vectors, we discussed something, right? Pythagoras theorem, blah, 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 separating it into its components. We have there and we have there, right? And when you take this and you create a triangle, that's how you can actually calculate their values. Okay, so that's how this whole thing is working. That's why we separate things into their components. Now I have it in its components. Perfect. So now, do I have any diagonal forces? No. I've gotten rid of all of my diagonal forces. I have exactly what I want to answer the question. I have all my forces in the vertical plane, all my forces in the horizontal plane. Okay, done. Now I can say FNet. Let me open up FNet. Tell me again quickly, what is the direction of motion for this question? What is the direction of motion for this question? Right, exactly. Okay, it hasn't changed, obviously. So the direction of motion. So remember, I say forces in the DOM, which is the direction of motion, minus forces opposite to the direction of motion. That's how I break up FNet. Now tell me which force this is how you pass Newton's law. Your free body diagrams have to be perfect. If your free body diagram is perfect, you have solved the question. Okay, which force is in the direction of motion? I see an Fx. That is 100% correct. F applied X is actually the force that's in the direction of motion, not F applied. Even though, yes, technically F applied is the force that's being applied and it's moving this box to the right. Its component, its horizontal component, is the component that's moving this box to the right. Okay, and yes, the other component is actually moving it up, technically. Okay, so what are my forces in the direction of motion? Maybe let's do this. Let's change the color. And then let's change this color. So my forces in my direction of motion, we said are F applied X. Now I'm going to subtract all the forces opposite to the direction of motion. Give me the forces opposite to the direction of motion. Just utilizing this. So remember, if my direction of motion is to the right, then opposite would be to the left. So what are my forces that are opposing the direction of motion? Ft and Ff, very good. So I'm going to minus Ft. So you can either minus them individually, like minus Ft, minus Ff. Alternatively, you could put them in a bracket and add them and just subtract them as a whole bracket. I just prefer to subtract them each individually. Doesn't really matter. This is equal to 0 because it's Newton's first law, stationary object or constant velocity. Fax. Now, in order to determine Fax, now, I don't know if many of you already have a preconceived notion of how to calculate components. Like, okay, if it's opposite or if it's X, it's always sine. If it's Y, it's always cos. Okay, I would stray away from that. I'm going to tell you the only one that you can assume. Okay, and it's actually FG parallel. Okay, we'll get there, or FG parallel or FGX. It's the only one you should ever go into an examination knowing 100% what it is all the time on an incline. Okay, we'll get there. However, this, do not ever assume. Do not assume F applied. Do not assume any other forces, any tensions that are skew. Always go to the diagram and calculate it. How are you going to do that? It's simple. Okay, so what you do is you go to the diagram and you identify your F applied. Okay, and it's 36. You then draw in its components in the form, in the shape of a triangle. So this is F applied X, and I complete the triangle like head to tail method, basically. I complete the triangle, don't mind it, it's a bit skew, with FAY, head to tail method. So this component and that component actually created that resultant. And then I analyze. So I have this degree. I analyze, okay, I have hypotenuse. The hypotenuse is actually the F applied. Okay, I have the value of hypotenuse, it's 36. Now, which one do I want? I want FAX. Relative to the 30 degrees, is FAX adjacent or is it opposite? Is it opposite or is it adjacent? We can see that FAX is adjacent. If it is adjacent, you are going to use cos. If it is opposite, you are going to use sine. You are going to say the formula for FAX is going to be F applied times sine theta. The formula for FAY is going to be F applied times cos theta. Okay, just remember that. Any force when breaking into its components, it's going to be that force itself multiplied by either sine or cos the angle, depending on whether it's adjacent or opposite to it. So in our case, it's FA sine theta. No, this is incorrect. It's cos, sorry. Opposite. It's not opposite, sorry. It's adjacent. FAX is adjacent. So it's going to be F applied times cos theta. Okay, because it's adjacent, right? FAX is adjacent to the 30 degrees, so we're going to use cos. And then FAY is opposite, so we're going to use sine. Thank you. That must be correct. Yeah, sorry. Okay, so now it makes sense because FAY is opposite, we use sine. FAX is adjacent, we use cos. So let's go and do that. We're going to say FA times cos theta. Over here, I'm going to say FA times cos theta. You don't have to break it up as much as this. You can just one time write it. I'm just doing it for the sake of explaining. What about tension? Tension we calculated previously is 29,4. And yes, frictional force. How do we get frictional force? Now, the set formula for frictional force, FF is equal to mu K. We are dealing with moving objects, times F normal. FF is equal to mu K times F normal. Now, tell me, does anyone remember? I don't think we've done it yet. So let me just write it. 3 notes. These are 3 important notes that you're going to remember. F normal. We have done it. Does anyone remember how do we calculate F normal? We did it in the first week. mg. Okay, I want you to take that mg, erase it out of your brain. F normal is not always mg, people. People like to assume that F normal is always equal to Fg, which is always equal to m times g. This is not always the case. It is always not the case. It can change. In general, if you want a statement that tells you how to calculate F normal in every single question, you are going to use this. Up forces equal to down forces. That's what you need to do. You need to take your up forces and you need to equate them to your down forces. And that is how you calculate Fn, no other way. If you have any other generalizations or shortcuts that your teacher taught you that is not this, take it and throw it in the bin. The way to get Fn 100% of the time is you need to take your up forces and equate them to your down forces. Okay, so let's do that in the specific question, right? So remember, I created this free body diagram, and I separated everything into the components that it needed to be separated in. Okay, that's exactly what I did. So I have all my up and down forces because I don't have any diagonal forces. So do you see what I'm saying? When you get to this, the question is solved because it's going to help you calculate normal and it's going to help you calculate Fnet, the two most important things. Okay, so firstly, Fnet, you use your horizontal plane because forces in direction of motion minus forces opposite to the direction of motion. And for normal force, forces that are up equated to forces that are down. Now, let us do it. F normal. It is equal to, no, let's not do that. Let's do this F normal. We're calculating it. Forces that are up. What are my up forces? Somebody tell me. What are my up forces? Do you see? I can directly look at here and reference. I don't even have to go back to the question. Once I have my free body diagram perfect, I don't even have to go back to the question. I can answer everything from the free body diagram. What are my up forces? Fy and Fn, correct. So what I do is when I have two forces in the same direction, like two up forces, I add them. So I have Fn plus Fay. So what did the rule say to get Fn? The rule said that whenever you want to calculate Fn, you're going to take your up forces and equate them to your down forces. Maybe we can say sum of the up forces is equal to sum of the down forces, right? Then it makes more sense. Because we add up all the up forces and we add up all the down forces. Okay, so that's it. Fn plus Fy is equal to what? What are my down forces? So N is only equal to Fg if the up forces and down forces are equal. Okay, okay. Let me answer this question and I'll show you the only time where N is equal to Fg. It's basically if there's no diagonal forces influencing it, but it's a bad way to remember it because look, when you start off Newton, you are of course going to do easy questions in the examination paper, especially in your final examination paper. They are not going to ask you an easy question. I can get, okay, maybe they will, and then the other sections will be hard, but it's like a high percent that they're not going to ask you an easy question. So why go to a default assumption for an easy question? Like an easy question is when Fg is equal to N. That means there's no other forces involved. Why default to that as your explanation? Rather default to all your up forces are equal to all your down forces. And in that case, if let's go to, in that case, if for example, you have a free body diagram where Fg is down, this is the only forces. These are the only vertical forces. This is the time when Fn is equal to Fg because all the up forces are equal to all the down forces. This is the only time when that is true. It's when your only up force is Fn and your only down force is Fg. Then up forces are equal to down, so Fn is equal to Fg. You understand? It's just that you guys do a lot of maybe basic questions in the start, and then the teacher's like, oh yeah, Fn is equal to Fg, or however wrong, I don't know. But somehow students always just default that Fn is equal to Fg, but it's not the case. The true correct thing is that up forces are equal to down forces. Right, is equal to Fg, very good, very nice. So now we can calculate from there. So Fn essentially is going to be equal to FG minus FAY. I hope you guys can agree with me. I took that over to that side. Now, FG is simple to calculate. FG is M times G. So basically 5 times 9,8 minus FAY. Now I go back to my diagram and I see, oh yeah, what did I write for FAY? Oh, FAY is actually opposite to the 30. So therefore it's FA times sine theta. Simple. Again, many people like to default that whenever you're working with applied, whenever you're working with applied, FAY is always sine and FAX is always cos. Never. Do not assume that 100% of the time. Again, the only one I'm going to tell you is this one. FG parallel on an incline. When we do the question, let me just write it. This one is M times G times sine theta, which is basically FG sine theta. And then obviously, like the other one would be FG perpendicular. Like if you learn one, you know the other one. But this implies that FG perpendicular is MG cos theta. This is the only thing you can assume. The only thing you should buy hard going into the exam. Okay, don't make your life hard, because it may seem like it's making your life easier to just memorize, oh, this component is that and this component is that. But the questions differ, the questions change. Like it might seem right in the first few examples that you do and it works, but then in the exam you get a box like this, and then they give you some funny applied force that way, but the direction of motion is that way. Then you're going to be in trouble, okay, because now it's slightly different. So let's not put ourselves in that situation, okay? So let's just go through it one more time. F net, okay, is equal to forces in the direction of motion minus forces opposite to the direction of motion. Friction is equal to mu k times Fn. How do you get Fn? You always say up forces are equal to down forces, okay, 100% of the time. What's extremely important is to draw your free body diagram with your vertical and your horizontal forces only. You don't want any diagonal forces in your final free body diagram, okay? Then, okay, now we're solving here. So we know that FAY is actually FA, which is 36, I believe, 36 times sine 30. Okay, I'm going to do this calculation entirely in my calculator and get one final answer. Please check if I am correct. Right, I'm getting 31 newtons. Fn is equal to Fg when there is no diagonal force. Okay, so I think I answered that question, right? Someone asked in the Q&A. I don't know if that's you as well. Right, so that the Fg is equal to Fn is equal to Ft. Yes, when there's no diagonal force affecting that specific object. Okay, you see, that's not also like you can't default to say that Fn is equal to Fg when there's no diagonal force. What happens if you have a question where, like, okay, the chances are low, but if you have a question where, like, there's a box on a table and then there's a force that's pulling it directly up, okay, then in that case, now you have Fg going down, you have F applied going up, and you have F normal going up because it's on the surface. So I don't know, whatever it is, right? But at the end of the day, in that case, yeah, there's no diagonal force. But in this case, Fn is not just equal to Fg. Okay, so don't default to that assumption. In many easy cases, if there's no diagonal force, yes, Fn is equal to Fg. However, to be certain and 100% correct, then just utilize this, that Fn is equal to, how to get Fn, sum of the up forces is equal to sum of the down forces. Right, now that we have normal force, we can use this normal force to get our frictional force. The frictional force is equal to mu k. Is mu k given? I think that's it's supposed to be given. Oh, no. Sorry. I've done this whole tangent for no reason, but it's fine. Will help us in the next question. They said calculate the frictional force between the surface and the 5 kg block. Okay, so in this case, actually, friction is our unknown. Okay, so yeah, that's the next question which we'll answer. So all the things that we actually did was for the next question, but it's fine, we'll move it. They want us to actually calculate mu k for the 5 kg box. Okay, but in this case, so see, this case was a Newton's law 1 question where it was equated to 0. Yes, correct. Thank you so much for that. I see that now. Okay, I forgot about that. So it's equal to 0. So we don't actually have to open up friction just as yet. Okay, so let's calculate all of this. I'm just going to erase this because we did it above, and I'm going to say 36 times just cos 30. Okay, so I'm going to do these calculations. So 36 times cos sine 30 minus 29.4, and I'm going to take friction over at the same time, and I'm going to have friction as positive, and when I do this calculation, I get 1,78 newtons. So frictional force has been solved as 1,78 newtons. I hope you guys understand that, right? So all of this, now I'm going to move to the next question and you'll see why. Okay, so we utilize the F net is equal to 0 formula to solve for friction. Now we have the value of friction. They want us to work backwards now and calculate the mu K. Yeah, Newton's does take long actually. It only gets better once you have practice. When you have practice, then it starts to speed up. Okay, so calculate the mu K for the 5 kg box. Okay, so in this case, right, we have friction. Now we know that frictional force is equal to mu K times Fn. Okay, so since we have the friction, we can calculate the normal, then we can calculate mu. So we've already calculated normal, right? We've utilized up is equal to down, up forces are equal to down forces. We've gotten the normal force. Then, okay, we use Ff is equal to mu K times Fn. Ff is, what is it? 1,78. Mu K is mu K, we need to solve it. And that is 31. We get a mu K of 1,78 divided by 31. I'm getting an answer of 0,057. No unit. It's mu K. I just was supposed to do this. It's not UK. Mu. So just type. So that's fine. Yes, mu is a letter in the Greek alphabet. Correct. Okay, so yeah, we solved for mu K. It doesn't have a unit because mu K is like a ratio. Essentially, what mu K is it's a ratio that tells us the friction between like two different surfaces. Okay, so that was one question. Okay, calculate mu K for the 5 kg box. Okay, so let's continue. Like let's try and, for those of you who have to leave because you have scheduled to this time, you are free to leave. For those of you that want to stay, I probably want to finish this whole question. The applied this 2.6 and 2.6, I guess 2.6 and 2.7. Okay, so let's just recap. Okay, the object. Okay, so it's a constant velocity question. So F net was equal to 0. We have this 5 kg object with an applied force pulled up to the right. Maybe let's get rid of this. It's not so cluttered. Let's move this down. Okay, so yes, yeah, the applied force is pulling this object up. The 5 kg object is moving to the right. The 3 kg object is moving up. Okay, we did free body diagrams. We could calculate the tension. Okay, just using one of the objects. Okay, because it just has two, up is equal to down type thing. And free body diagrams, force body diagrams, the main questions. Okay, now let's move over to this. It says that the applied force is now changed to 67 newtons. Okay, 67 newtons. Calculate the magnitude of acceleration of the system, 5 marks. Magnitude of tension in the string, 2 marks. Okay, so one thing we need to note is, so firstly, the do this. Magic. Okay, so firstly, the magnitude of the applied force that was pulling this object up was 36 newtons. Okay, and when this person, okay, was standing on top of this thing and was pulling this 5 kg box with 36 newtons exactly, with 36 newtons, it was moving at a constant velocity, meaning that the forces that were pulling it were equal to the forces that were pulling it back, basically, and it was just moving at a constant velocity. Now, as soon as you apply more force, 67. Okay, so now it's no longer, what is it? What was it? 36. Now the applied force is 67. So the force at which this box is being pulled is a lot more, almost double, okay, than what it was being pulled. So what you need to note is that this object is not going to move at a constant velocity anymore. Okay, there is going to be an acceleration because I know for sure that now that I'm pulling with more force, it's going, the forces to the right are going to be stronger than the forces to the left, because originally they were equal because constant velocity, right? But now I know for a fact, because I am pulling it with more force to the right, that they're not equal anymore, and the force to the right is bigger than the force to the left. Okay, so that's why this question is different. This question is now Newton's second law, where we have an acceleration. I mean, another hint is the fact that they actually ask you for acceleration. So you're like, okay, there is an acceleration. This is Newton's second law. Okay, typical question. Let's work through it. No, there's no such thing. If you get mu k as negative 0.05, do you just ignore the negative? No, there's something wrong in your calculation. Double check it, because you see, I took this over, which made FF positive, and then this gave me a positive calculation. There's something wrong. Oh, sorry, we're working here. If you're getting negative, that means you're having negative friction or negative normal. So something's wrong, just check it. Okay, so yes, calculate the magnitude of acceleration. Okay, so in this case, right, a lot of the times they want us to calculate acceleration and tension. Now, sometimes they'll ask it in a separate question, and it will separate marks. Okay, sometimes they'll ask tension or acceleration, right? You did Fy minus Fg, not Fg minus Fy. That's incorrect because of this. Fn plus Fay is equal to Fg, and you need to take this guy over. And you get that. So that's incorrect. That's why you're getting negative. Okay. So, okay. So sometimes, again, like I said, they'll ask only tension. Okay. But your instinct in Newton's second law, when they ask for acceleration, okay, is to do simultaneous equations. You need to create an F net is equal to m times a for each object and work from there. Because each object, you know why actually, right? Because what's the same? Okay, can somebody tell me what two things are the same between these two objects? If I could give that person a chocolate, I would give them the perfect answer for this. Two things. I don't accept tension. I want it more specific to it so that it's 100% correct. Tension is a force. A force is a vector quantity which needs direction. So what is the same? The tension is not the same. The magnitude of tension is the same. Okay, that's the first one. The magnitude of tension is the same. What's the second thing? Not the F applied. The F applied is only acting on the 5 kg object, by the way. Yes, the F applied does have an effect on the 3 kg object, but that's through the rope. So it forms part of that tension, actually. This tension that's pulling this object up is actually getting its power from that applied. The F applied, the direction, no, somebody. Fn, nope. The 3 kg object does not have a normal force. The 3 kg object does not have a normal force because it's not on a surface. The Fg is different because they have different masses. The shape of the boxes, definitely. Shape of the boxes are definitely the same. I can't argue. So there's actually a third thing that does the same what they do. It is the magnitude of acceleration. Yes, well done. Somebody got it on the YouTube chat. It is the magnitude of acceleration. Okay, because remember this operates as one system. Okay, so the 5 kg box and 3 kg box operated as one system. They move together. Okay, because they are attached with this light inextensible string. Okay, so the acceleration of the 5 kg box is the same as the acceleration of the 3 kg box. So we have acceleration that's the same here. We have tension that's the same. Acceleration, tension. We have two. Well done. Okay, we have two variables which are identical. Okay, why do the messages on YouTube keep getting retracted? Are you guys deleting it, or is it getting like automatically deleted for some reason? What was I saying? Yeah, we have two variables which are equal for two different objects. Okay, simultaneous equations, two variables, two equations. Okay, so yes, in that case, so ideally what we want to do is we want to set up an Fnet is equal to m times a for each object. So I'm going to start off with my 3 kg block. Okay, and I'm going to say Fnet is equal to m times a. Now Fnet, right? What I'm going to do is I'm going to steal these. One, two. Okay, so for the 3 kg object, tell me Fnet, how do I open up Fnet? Good people, how do I open up Fnet for the 3 kg block? Ft minus Fg, correct, because the object is moving in the upward direction because that moving to the right, so that means that moving up. So the direction of motion for the 3 kg object is up. Remember, Fnet is equal to forces in DOM minus forces opposite DOM, correct? So Ft minus Fg. Ft minus Fg is equal to m times a. Now tell me, Ft, can I use the same tension that I calculated in the previous question? I calculated the tension for the object as 29,4 in the previous question when it was at a constant velocity. Can I use that same tension in this question? Now that it's not moving at a constant velocity, it's moving at 67 newtons. Well, the applied force is 67 newtons. We have a yes and we have a no. We have another no. We have a no. Okay, the answer is no. Okay, the reason for that is because if you can use the same rope, no, it's not about the same rope. Okay, remember, what is tension in the rope created by? Like, let's think of this logically, right? Because due to this, like, imagine there was no applied force. Imagine we had no applied force, nothing. Okay, and this object was just hanging. Okay, even if there's no pulley, right? This object was just hanging. The rope would literally fall, lay down, and then hold the object like that. Okay, the rope would not be taut, like, I mean, tight. Okay, it would be loose. Okay, so the tension in the rope is actually created by the fact that there's an applied force pulling it from the other side. If the applied force is pulling it, okay, it's allowing the rope to be taut, and it's increasing the tension in that rope. Okay, and like I said before, the tension in the rope is pulling this object up, but the tension in the rope is powered by this applied force. Okay, because it's pulling this object. This object is basically like pulling this rope, which is pulling that part of the rope, which is pulling the object. Okay, so firstly, you cannot use the same tension because the tension is going to be different because the forces are different. It's one thing that's important to note. You cannot use the same tension. Okay, simply because the F applied here now changes. Okay, and again, why would they ask us to calculate the magnitude of tension again if we could just use the same one? Okay, so tension is actually unknown. Fg, that's simple to calculate. That's 3 times 9,8. Mass is 3. Acceleration, also unknown. 2 unknowns. This is what you expect. Okay, so this is like your first equation, your first simultaneous. Now we do the exact same thing for the 5 kg object. F net is equal to m times a. So remember, F net is equal to forces in the direction of motion, forces minus forces opposite to the direction of motion. Please tell me, open up F net for me, please. How would you open up F net in terms of forces? Not FA minus FF minus FT. It's FX or FAX. FAX, that's the direction of motion right, minus opposite to the direction of motion, minus FT minus FF. Okay. FAX, I can calculate. Okay, so remember, how do I calculate the components of an applied force? I go to the diagram and I draw the triangle. Always draw the triangle. So I have FAX and I have FAY. Now FAY is opposite, so it's going to be equal to FA times sine theta. And FAX is adjacent, so it's going to be FA times cos theta. So FA times cos theta, remember FA is now 67. Right, frictional force. Tell me, we calculated the frictional force for the 5 kg block in the previous question. Can I use the same friction? 1,78. Could we use FA minus T minus FA? Yes, that's what we're doing. FA, we are saying FAX, not just FA, meaning like, sorry, someone asked a question in the Q&A. They said, can we use FA minus T minus FK is equal to MA to calculate the acceleration? So FA, not exactly, we need to use FAX, which are forces in the direction of motion. And yes, you need two. Yes, no, maybe. Yeah, I like that answer. Yes, yes, no. People are fighting against each other. Some are yes, some are no. The F applied changed. Yes, very good, very good, very good, very good. So since the F applied changed, let's analyze logically with our brains, which I hope that we have. Why can the friction not be the same? Okay, so remember, friction is what? Friction is FF. You should always, especially like sometimes they ask these theoretical questions, you can relate it to your formulas. Friction is equal to mu K times Fn. Mu K, okay, does mu K change? Okay, let me rather explain this to you. So firstly, mu K is constant. Okay, mu K is a constant. So mu K is a constant that tells us how much friction basically there is between the object and the surface. So this guy is constant. So he will never change. So that's not going to affect FF. Great. Okay, so FF hasn't been affected so far. What about normal? Okay, we don't know. Is normal effective? We don't know. Let's try and see. What is the formula for normal? F normal is equal to, F normal is, there's no formula. It's up forces are equal to down forces. Okay, let's take it one step further. What are our up forces? Our up forces, remember, are Fn and Fay and Fg. Fn, Fay, and Fg. Fn plus Fay is equal to Fg. Now I'm going to analyze. Did any of these change? Yes. Fay did change. Forgot. So Fn is equal to Fg minus Fay. Fay changed. Since Fay changed, Fn changed. Since Fn changed, friction also changes. Okay, I hope that makes sense. So F tension, yes, minus F friction, I have to go and calculate it separately. So FF, we've been through this, is equal to mu K times F normal. F normal, we get by saying up forces are equal to the down forces, right? My up forces are Fn plus Fay. My down forces are Fg. Fn is equal to Fg minus Fay. Fg stays the same, of course, 5 times 9,8. Fay, this is interesting. Fay, it's basically going to be 67 times sine, is it, yeah, times sine 30. Correct. Okay, when I do this calculation, 5 times 9,8 minus 67 times sine 30, I get an answer of 15,5. The normal force is now 15,5. So the friction, what about mu? What about mu K? They didn't give us mu K. Yes, same as the one we calculated. Got it. So even though like it's on the previous question, the fact that we calculated means, okay, we got the value for mu K. So no matter if we don't change the type of objects material and we don't change the surfaces material, which they didn't mention was changed, the only thing that was changed was the applied force, we can use the same mu K, okay, because that's constant. Okay. 0,057 times Fn 15,5. So we get our frictional forces, they're going to 5,7 times 15.5. Our friction is 0,8 newtons. Okay, so very little friction now. Correct. So 0,88 is equal to mass. What is the mass? 5 times acceleration. Now we simplify. So 67 times cos 30. It's going to give us 58,02 minus Ft minus 0,88 is equal to 5A minus 0,88. From that, you actually get 57,14 minus Ft is equal to 5A. Now we formed our second equation. You remember from simultaneous, your third equation is formed by isolating one of the variables. So that's exactly what I'm going to do here. I'm going to isolate Ft. Ft is equal to 3A plus 29,4. Hope that you guys can agree. 3A plus 29,4. And then wherever I have Ft, I'm going to substitute 3A plus 29,4. Remember the minus is going to affect it. So 57,14 minus open brackets. Please don't forget, whenever you're substituting anything, use open brackets. Use brackets. Plus 29,4 is equal to 5A. It becomes 57,14 minus 3A minus 29,4 is equal to 5a. I'm taking 3a over to the other side. I'm getting 8a. Okay, I'm adding it. I'm getting 8a. I'm saying 57.14 minus 29.4. And I'm getting 27.74. Divide that by 8, and I'm getting an acceleration of 3.47 meters per second to the minus 2. Anyone did it and got the same answer? Obviously, like here, you can skip some steps if you'd like, if you're faster with it. Like if you understand it, I'm just trying to show as much as possible just for perfect, just for the understanding purposes. Okay, but yeah, like if you find with algebra, you can maybe skip some of these steps and it will be a bit shorter. Okay, so that's acceleration. That's acceleration done. Tension is easy. We didn't even have to write that small. Okay, tension is easy because we have acceleration, and always in your rearranged equation in simultaneous is where you now substitute that variable. So I'm going to say Ft is equal to 3a plus 29.4. Ft is equal to 4, and I substitute the value for a. Ft is equal to 3 into 3.47 plus 29.4. 3 into 3.47 plus 29.4. You get the tension in the rope. It's 39.81 newtons. Okay, cool. So that's basically that, right? Let's see. So next week, what we'll maybe do is we'll start off on gravitational laws or whatever. And then we still need to do an equilibrium question. Okay, let's see. We can do Newton's third law and maybe an equilibrium question. Let's see how it goes. And then there's like a bunch of questions you guys can try on your own, and I'll just release a memo for them. And if you have any questions, you come and ask me. But yeah, look, if you're stuck, follow these methods, right? It's really, really important. I'll put this maybe like on the first page or like somewhere maybe on its own page as well. These are extremely important, and you need to get rid of all the rubbish that you know that is rubbish, because obviously you don't know all, not all that you know is rubbish, some is good. But yeah, like things like Fn is always equal to Fg. Okay, those are just bad habits. Bad habits. Okay. So yes, so Fn, sum of up forces, sum of up forces equal to sum of down forces. F net, okay, forces in the direction of motion minus forces opposite to the direction of motion. Fg on an incline, Fg parallel on an incline, we'll get to there, right? At some point, hopefully we have to do an incline question, I guess, like we cannot do an incline question. Maybe we'll do this one here. It's similar. They asked something in 2019 November. I think they asked it for like 8 marks. Just they wanted acceleration and tension. We'll go through that at some point. Hopefully we still need to do electrostatics before you guys test. Yes, the playlists will be updated. The playlist will indeed be updated. I'm gonna update it now, probably after this. But yeah, cool. Thank you guys so much for joining. If I'll leave it open for a few more minutes if there's no questions. Yeah. No problem. How are you guys finding grade 11 so far? Have they bombarded you with the grade 11 is so important and it's harder than grade 12 and you have to do well at the end of grade 11 and the universities are going to take your marks? Have they started? Because that's what grade 11 is about, telling you how much harder it is than grade 12. which is not true, by the way. Grade 11 is not harder than grade 12. Very tiring, hectic, too much work, limited time. That's the school. The model of school is too much work, limited time. How do you do 7 subjects? Crazy. Oh, somebody asked a question. Do you not teach life science? Unfortunately, not. We don't do life science. Life science is very hard. I would suggest with life science, find some really good notes. Find some really good online videos of certain topics. Yeah, that's what I would suggest. Like find some really good summary notes. I don't know. I don't have any. I'm not sure. Actually, they said I must get distinction from them too. Yeah, how? You have to push for distinction. Am I a teacher? No, I'm a student. Must angularly push my life science. Oh, is that a YouTube page? I don't even have a physics teacher. Hectic. Yeah, that's how school goes sometimes, eh? That's how it be. Okay, there we go, guys. Ms. Angler, for the person who said life sciences is really hard, why don't you try Ms. Angler? Like, look, I feel like for example, when I was in school, I had a terrible life science textbook. It made everything horrible to study. As soon as I got my hand on some good notes, it made everything a lot easier to study because things were a lot easier to understand and a lot easier to SWOT. And like, I don't know, I just prefer like bulleted points, like things that are straight to the point. I don't want something that's teaching me through a case study and this and that. So once I found good notes, that's what helped me a lot. So yeah, Ms. Angler is probably something that's really good if someone found it helpful. Teach better than my own teacher, that's a good thing. Yeah, teachers in school, I don't know. Sometimes it be like that. Do you have anything? Grade 11 trade, yeah, sure I do. What's your investigation specifically about? What you do is just message me to tell me that you need notes on trig so that I can send them to you. No problem. Trig functions, okay, so trig graphs. Can we mark? I did the investigation, it was depressing. Chemistry we covered this term in this classes. Probably not, eh? Just solely due to the fact that I'm following the government's teaching plan, which is just what most schools. Can you post the big notes in the group? I wouldn't like to because it's for physics, grade 11. So people are going to be like, why is there random trigonometry notes? Yeah. I would prefer that you message me so that I can send them to you if you'd like them. Yeah, so probably not, unfortunately. I know that many schools do go ahead and cover chemistry, which is good. So maybe what we can do is in the holiday sometime we can try and catch up or something. Again, I don't want to confuse people because we're currently not busy with trig. So don't you want to just message me and I can send it to you? I don't like schooling, so maybe that's why. Yeah, true. It could be. Also, I know like some schools have a dedicated physics teacher and a dedicated chemistry teacher. Now they can't have one teacher working one term and another teacher working another term, so they teach them physics and chemistry simultaneously. I know some schools do work different, like maybe not so much your government schools, but like other schools. So it is a possibility that you are doing chemistry this term. Unfortunately, like technically you're not supposed to be doing it. But yeah, next term we will, however, be doing atomic combinations and intermolecular forces. We haven't even done trig yet, but the investigation. Yeah, I suppose that is why it's called an investigation. You got to find out. Sure, investigations are meant to test your thinking through, but I mean, I feel like you should have a little bit of a background in it. Like you should know what's it about a little bit. Maybe it will rely on grade 10 trig. Like maybe that's enough. We make a WhatsApp group where we can ask questions on them. Okay, about the WhatsApp group thing, I can try and find out. We are working a way for you guys to ask questions. It's just obviously difficult to answer so many questions, being that I am a student myself. My teacher was like, yeah, okay, good luck, guys. I would suggest that like you guys message each other. If one wrote the investigation, the other one finds out about it, you know, connect. You see what it's about. Maybe they can give you an idea of what it's about. So yeah. But okay, cool. Let's end it there. Thank you guys so much for attending, for joining. All the best with your guys' week. For those of you who are still busy with momentum, good luck, because you shouldn't be busy with momentum. For those of you who are busy with, I think most of you are on gravitational law, Newton's third law, and then some on electrostatics. All the best. Enjoy. Let's hope that you guys learn, and I will see you guys next week, same time. Okay, perfect. Thank you. Assalamu alaikum.